first of all, please write the heading Laplace transforms. Please put the heading Laplace transform. Please put the heading Laplace transform. Now, I know that a question may arise in your mind, why we are studying the Laplace transform in the IPC? What is the need of it? What is the need of it? It is clear to you or not? So first we will try to understand the importance of the Laplace transform. Laplace transform is a very fantastic thing, guys. Very fantastic. This operation is. How? See. First of all, we have to deal with the differential equations. Okay. We have to deal with the, you can say, the integration problems. Right? It is clear to you or not? It is clear to you or not? And there are number of, you can say, there are number of difficult mathematical operations are there, and we have to deal with it. Okay, so generally for the process control, we have to deal with the differential equations. And the beauty of the Laplace transform is that the Laplace transform converts this differential equation into the algebraic equation. And guys, you know, I know that to deal with the algebraic equation is very easy for us. Most of the dynamics processes are modeled with the differential equations, guys, right? And so Laplace transform basically convert these into the algebraic equations, and this is, you can say, easy for us, or you can say easy to model any process with the Laplace transform. So for you, I'll write all these information what I'm saying. First of all, what is use? Okay, use is, it is basically the simple development of, please write all these things, simple development of input output models which are very useful for control purpose. Please pay attention here. Everybody, please pay attention here. Another, please write it, that most of the dynamics processes, are modeled with differential equation. So Laplace transform, please write all these things, okay? Laplace transform converts these into algebraic equation, right? Please write all these things and let me know that you are done with this or not. If you are done with this, let me know, guys. If you face any problem, let me know, okay, without any hesitation. If you want to ask, please ask. Doesn't matter that on which platform you are watching, just let me know through the message. Great. Now, okay, good. Now the question is that, okay, sir, we'll use the Laplace transform because it will help us to develop the input-output models, and also it converts the differential equations into the algebraic equations. Now, coming to the mathematics part. Now, what is this basically? The Laplace transform. Okay, so first of all, try to understand it, guys. Let's suppose I have a function f of t. I have a function f of t, right? And t is basically greater than equal to 0, right? For t is greater than equal to 0, let's suppose my function ft is defined. Okay, we are not talking about undefined functions, we are talking about only the defined functions. I have this f of t, right? Is it clear to you or not? Okay, so if, just try to understand it, I have the two variables, one is t and one is s. One is t and one is s. Okay, I'll tell you what is this, all these things, right? Now, I want to do the Laplace of f of t. I want to do the Laplace of f of the t. Then how we can do this Laplace? So actually, Laplace is a integral transformation, you can say. It is an integral transformation of a function. Like this is my f of t. And if I want to calculate the transfer function, calculate the Laplace transform of this f of t, then first of all I have to multiply with e raised to power minus st, right? And I have to integrate this function. I have to integrate this function from 0 to infinity. Whatever this value we are getting, that we will say, okay, that this is the Laplace transform of f of t. So if I will calculate the Laplace transform of f of t, then this is the notation of Laplace of the f of t, and that will give us the f of s. After the Laplace transform of f of t, I am getting f of s. F of s is the value of the function after the Laplace transform of the f of t. So there are two variables, t and s. Right? It is clear to you or not? Both t and s are the independent variables. Okay. I'll write here both t and s are independent variables. Right? Here t is the time domain, s is the frequency domain. This is my example number 1. Please try to calculate. Let's suppose my f of t is equal to 1 and this is defined for t is greater than equal to 0. Find the f of s. And meanwhile, just let me give your answer if anybody solved this question. It is very simple. If I want to do the Laplace of f of t, then it means that it is my integration 0 to infinity e raised to power minus st multiply by f of t. F of t value is 1, so it is my 1 into dt. Right? So what is this? Laplace of f of t is what? It is my f of s. What is it, guys? I think it is very simple. Yes or no? It means that you have to find out the integration of e raised to power minus st. Yes or no? It is my e raised to power minus st. Multiply or divide, guys? I think in the integration it is divide. Divide with minus s. Yes or no? So what is the everybody is aware about it? Integration of e raised to power minus st. Yes or no? And now just apply the limits. So f of s is equal to minus 1 upon s into e raised to power minus infinity minus e raised to power minus 0. E raised to power minus infinity is 0. E raised to power minus 0 is 1. So it is minus 1, minus minus plus. So what is my f of s, guys? My f of s is 1 by s. Yes or no? It is clear to you or not? So Laplace of 1 is nothing but it is my 1 by s. This is your answer. Next question. Now I'm saying that we have to calculate the e raised to power 80. Very good. Okay. Pranvika, 1 by s minus a. Okay, let's see. Let's see, Pranvika. Okay, let's start this. I think you got your answer, guys. Let me solve this problem. Now, very simple. Again, I'll start the process. Laplace of e raised to power 80. So what will be the Laplace transform of this function? It is my integration 0 to infinity. First of all, this is my function and I have to multiply with this function to the e raised to power minus st into dt. I can write this as 0 to infinity e raised to power a minus s into t into dt. Yes or no, guys? I think that it is clear to you. Yes, is it clear to you or not? Okay. Or I can write this function as 0 to infinity e raised to power minus s minus a into t into dt. It is clear to you or not? What is the integration of it? What is the integration of it, guys? I hope that there is no problem in the integration. There is no problem in the integration. Clear? Okay. So I think it is my e raised to power minus s minus a divided by a minus s. A minus s. Yes, it is clear to you or not? Right, now we will put the limits. Okay, it is my 1 divided by a minus s into e raised to power minus s minus a into infinity minus e raised to power minus s minus a into 0. So it is my 0, it is my 1. So it is my minus 1. Can I write this? F of s is equal to 1 divided by s minus a. This minus and minus, this is my f of s. Yes, yeah, Pranvika, so your answer is correct, Pranvika. Your answer is correct. F of s is 1 by s minus a. So Laplace of e raised to power at is basically 1 by s minus a. Sir, if we have to do the integration each and every time, then what is the benefit of it? Yes, you are correct, guys. You are correct. If every time we have to do the integration, then what is the point of simplicity? You are correct. Okay, so don't worry about that. We will remember, we will know some, after knowing some properties of the Laplace transform, we will calculate all the transfer function without any integration. Don't worry about that. Just to make you understand what is the Laplace transform, what is the basic of the Laplace transform, or you can say what is the root of the Laplace transform. It is coming from the integration. I'll just repeat, I just follow this path. Okay, in the future we will not do the integration to calculate the Laplace transform of any f of t. Don't worry about that. Okay, don't worry about that. Is it clear to you? Okay. So this is a table, guys. This is a table. In this table, there are 12 number of formulas are there, right? And we have to remember all these, you can say, the formulas. These are very basic formulas, right? Some of formulas we will, you can say that we will calculate the transfer function of the some of the formulas, but like in at the start of the lecture we just calculate the Laplace transform of the 1. Laplace transform of the 1 is equal to 1 by s. We should know this. We should know this. Laplace transform of e raised to power at is 1 by s minus a. Right? Laplace transform of cos omega t. See, there is no need to calculate each and every formula with the help of integration. There are, you can say, 10-11 formulas which are important for us. Okay, or if I'll say that this one, this one, this one, this one, this one, these are the important formulas. These are the important formulas. We have to remember all these formulas. Okay.